Linearizing a binary indicator variable based on an integer variable in PuLP. Problem overview. When modeling optimization problems with PuLP, you might want a binary indicator variable based on the value of an integer variable. For example, given an integer variable s which can be 0, 1, or 2, define a binary variable y such that y equals 1 if s is 0 or 2. Y equals 0 if s is 1. A naive approach to represent this relationship may introduce nonlinear constraints, like multiplication of binary variables, which PuLP and typical MILP solvers cannot handle directly. The challenge of nonlinear constraints. One may try introducing two additional binary variables z1 and z2 and constrain them to reflect the relationship. However, the product z1 asterisk 1 z2 is nonlinear and thus not suitable for MILP solvers. Linearizing the indicator variable. To avoid multiplication, introduce a single auxiliary binary variable s1 alongside y. Use the following linear constraints. How this works. For s equals 0, s1 equals 0, y equals 1 to 0 plus 0 equals 1. For s equals 1, s1 equals 0, y equals 1 to 1 plus 0 equals 0. For s equals 2, s1 equals 1, y equals 1 to 2 plus 2 equals 1. The auxiliary binary variable s1 serves to compensate for the case when s equals 2. Benefits of this approach. Purely linear constraints compatible with MILP solvers. Easily extendable to other indicator-like relationships. Avoids complex auxiliary variables and nonlinear expressions. Takeaway. When you want a binary indicator variable to reflect conditions on an integer variable in PuLP, avoid products of variables. Use auxiliary binaries to linearize indicator logic. Express relationships with linear equalities and inequalities. This technique is a simple and effective way to model piecewise logic inside a linear optimization framework.